Hi guys, welcome again. So in this particular class, what we will be looking forward to is prime numbers, highest common factors, and the lowest common multiples. This is basically after taking the factors. So if you haven't checked out the factors video, then you can basically check it out. And then yeah, let's go into prime numbers. So basically prime numbers, and I mean the rest of this class is based on the factors, right? So it's still based on the idea that we're trying to split complex numbers, like really big numbers. We're trying to split it down into very, you know, small numbers. So what is a prime number? Now, a prime number is a number that only has two factors, right? And then the two factors are one and itself. So this is the idea of what a prime number is. So a prime number is one, for instance. A prime number here could be two, sorry, three, 5, 7, 11, 13, 17, 19, 23. So what is common with these numbers, right? These numbers are numbers that you cannot split. So if you try to find the factors of this number, you will notice that after you start the first chain, you will stop there. So basically you could have for 2, like if you want to find the factors of 2, you start from 1. And then when you try to go to 2, basically it's the same thing. So the only factors of 2 is 1 and 2. When you try to find the factors of 3, the only factors of 3 is 1 times 3. And 2 is not possible to be a factor. It cannot multiply up to 3. So basically the only other possibility is 3 multiplied by 1. Also, the same thing goes for 5. 1 times 5. 2 cannot multiply to 5. 3, not possible. 4 as well. And then you have 5 times 1. So you notice, like in these numbers, you can only multiply only 1 to get them. So this is what a prime number is. And because we could, in mathematics, you could come across different type of questions where you're basically asked to find what are the prime factors. Now, a prime factor is just a prime number that multiplies up to a certain number. So, they come up with terms like prime factor. So it's like just basically breaking down a number to its lowest form of granularity. So if you were to find the prime factor of, say, 64, or let's maybe go with another number like I will say 90, for instance. So just a moment, or let's just even keep it at I'm just looking for that okay, like let's say we keep it at 280. So we're trying to find what is the prime factor of 280, right? So in this case, we try to break down 280, and then we look at the parts of it that is a prime number, right? So this is how we go, right? So we go 280 now. So you have 1. Sorry for that. So you have 1 times 280, right? And then when you try to go further, you see 2 is possible, and you have 2 times 140. When you try to go to 3, 3 is not actually possible. In this case, you cannot find 3 multiplied by anything to give you 280. So you basically go to the next number. Is 4 possible? Yes, 4 is possible. 4 times 70 will give you 280. And 5 is also possible. So 5 times there should be 56. will give you 280. Is 6 possible? No, 6 is not possible. Is 7 possible? Yes. 7 times 40 will give you 280, and then we go to 8. Is 8 possible? Yeah, I think so. So 8 is basically like saying, you know, 8 should give you 35, yeah. And then is 9 possible? 9 is not possible. Is 10 possible? 10 is possible, yes. And then we go to 11. Is 11 possible? No. 12 possible? No, 12 is not going to divide. It's 13, not 14, no. 15, 16, 17, 18, 19. All these numbers are not possible they're not possible factors of 280. So we get to 20, which is actually a factor. So for 20, what gives us 280 in this case is 14. And then we go to 21. Is 21 possible? I think it's not possible. So 22 as well is not possible. 23, it's not possible as well. 24, 25. So 26 is also not possible. And then you have 27. And then you get back to 28, right? So at this point, you have 28 times 10. So here you have like the similarities, right? Also here you should have like 14 times 20, and that should have been the breaking point for us. But we kind of skipped it. So here now we look at all the factors and we say, okay, this is all the factors. The factors are here, right? These are the factors, right, of 280. But then when we look at all these factors, one thing we could see is that it's not all of them that is a prime number. So if we were to find the prime factor of 280, we will come to the conclusion that the prime factor is 2 times 5 times 7. These are the prime factors. These are the ones that are prime numbers. So these are the ones that we call a prime factor, right? So if you want to find what a prime factor is, the first step you take is you first find what is the factors, right? This is the steps of, steps 2. You first calculate what are the factors, right? What are the factors? You find the factors, and then you select the prime numbers, right? And then there is also this popular debate of is 1 a prime number or not. So 1 does not qualify as a prime number. And this is because, the definition of what a prime number is a number that has 2 factors, 1 and itself. So 1 doesn't have any other factors aside from itself, which is also 1. But basically, it's kind of, kind of defies the odds. So prime factors start from, prime numbers actually start from 2 upward, basically. So in this case, our calculation of the prime factors of 280 is giving us like 257. If we were to also calculate for what is the prime factor of maybe 63, for instance, as a number, you could pause the video and give it a try. But then I will just go ahead now and say what the answer is. So you have 3 times 7. Another factor of this kind of, for 63 could be 9. So basically you do not 9. Why? Because 9 can be broken down to 3 times 3, right? So not 9. Also, we could, take another example that you could basically give a try. So, 108, for instance. So here you have 2 times 3 which is like times I think 2 and 3 are the major here. So I mean, you could see a lot of examples where they don't qualify in this case. So you have 9 here, you could have 6 here, you could have 2 here. I mean basically these examples I've given, you could just give it a try on your own and basically break them down into parts and then do your computation on that. So yeah, this is prime numbers, right? So prime numbers, prime factors, which is very interesting. So now we could go into highest common factors, and then from there we will go to lowest common multiples, and so let's go like this. So just wipe this out. Okay, so just a moment. So now we go to the next number, which is now highest common factors. So we have the highest common factors here. Yes. So what is the highest common factor and why do we use it? So first, the highest common factors is just basically like comparing a certain number, set of numbers, and comparing what is the common factor, amongst all of them. So what is the common factor among, so for instance, you have like, you have two numbers. So you could, maybe trying to compare, say you want to compare like, maybe 64 and 48, for instance. So these numbers, you have 64, you have 48, right? So what is the idea behind this? The idea here is, trying to understand, the easiest way to divide these numbers. So, if for some reason, we could also be trying to group these numbers in a certain type of way, right? We could come across these numbers down the line. This type of examples will still be very useful. So the idea is here, we're trying to group the numbers, right? And then we're trying to know what is common. What is the highest, similarities that these two numbers have in their factor chain, right? So then here we will just look at, we just try to break down the numbers. And there, I will say like two different ways that we could go about this, but let's just go down here. So first, what is the, in this case, we look at what is the steps. So the steps to HCF is you first find what are the factors of all numbers here. And then you look for the highest. Similar factor. So highest here is in magnitude. So basically, what is the highest number that is common for both of them as factors? So here we try to break down 64. So 64 is 1 times 64 is possible. We know that for 1, 2 times 32. 3 is not possible in the case of 64. 4 is possible, 4 times 16. 5 is not possible. 6 is also not possible for 64. 7, 8 is possible, 8 times 8, right? And so the next one in this case is 11. 9 is not possible. 10 is not possible. 11, 12, 13, 14, 15 is not possible. So the next one is 16 times 4, right? So in this case, we already have a situation where we have the same, the same numbers adding up. So here are the factors of 64, right? And then we go to 48, right? So in the case of 48, what are the factors? We have 1 times 48. Then we have 2 times 24. Then we have 3 times 16. 4 is possible, so 4 times 12. 5 is not possible. 6 is possible, actually, 6 times 8. 7 is not possible. 8 is not possible. Oh, 8 is possible. So we have 8 times 6. And then here we have, we have all the possibilities. So because here we already completed the chain. And so here we basically know what are the factors here. So we know that the factors here are 1 to 6 and then 8 to 16, right? So we have 1, 2, 3, 4, 6, 8, 12, and 16, right? And then if you look at it now, for 64, you could easily see that the factors are 1, 2, 4, 8, and 16. And then for 64, this is for 64, sorry. And then for 48, you have 1, 2, 3. Sorry for that. 4, 6, 8, 12, and 16, right? So in this case, and we also have 24 and 48, sorry. Okay, now this is... Actually, here also we have 32 and 64. So we have 32 and 64, right? So here you have 16, you have 24, you have 48. So what is the common factors? What is the highest common factors? We could easily see that the common factors is 2, because there is 2 here, there is 4, there is 4 here, there is 8, there is 8 here, there is 16, there is 16 here. Now, is there any other one? No. You have 16 and 16. That is the range. So in all these common factors, the highest of them all is 16, and that makes our answer 16, right? So this is it. So when we look at the highest, we're looking at it from a magnitude perspective. We break down the common factors, we break down the factors of each individual number, and then we try to compare what is the highest number, right? And here we come to the conclusion that this is the highest common factor. So yes, so here we come to conclusion of what the highest common factor is. You could also give this a try. You could just pick up 2 numbers and try to see if they have any common factor. And then you can make the highest common factor, right? So now here we will move straight to the next topic, which is basically like lowest common multiples. And so let's go deep into it.